The difference between the sparse mode and the dense mode is the dense mode floods and prunes. We saw example. But flooding and pruning is not good because there is waste of bandwidth, waste of process utilization. We want only those interface that really needs the traffic need to be flooded. Not all the interfaces that runs PIM. We want the multicast traffic to go only on those PIM interface where there is a receiver at the end of the circuit, at the end of the topology. Very well. For example, if I have a receiver here behind R7 and behind R5, I don't want the link between R6 and R2 to forward or process the multicast traffic. Likewise, I don't want this link, the G4 of router 2 and G1 of router 2 to forward the traffic. Let's go one more time and check the dense mode before we go and configure the sparse mode so that we will get a better picture. Earlier we have configured the routing protocol OSPF as a routing protocol, and we got the routes, and we were enabling PIM dense mode, and then we also joined IGMP groups on router 7 loopback and router 5 loopback. We tested once pinging from this router, pinging that multicast address 239.10.10.1, and we received the reply only from router 5 and router 7. That's a very good output. But we also saw the multicast traffic was flooded on this G01 interface, G04 interface, and here on G01 of router 3 where there is no receiver. So it was flooded and pruned back. We saw that earlier. We are going to have one more time to look into these things, and then we'll get into sparse mode. See, the router 2 is ready. I'm using router 2 because router 2 is the best place to see the flooding and pruning. So now we have not done any ping. Before pinging, this is the status. Show mroute. Mroute is the command. Show IP mroute. It's still an IP packet. It's not a multicast packet. It's not MPLS packet. It's a multicast packet. It needs IP. So show IP mroute. Now this router will not know anything about 239 or 10.10.1. See, there is no mention about 239.10.10.1. We got only 224.0.1.40. As I said earlier, this is a default multicast group which every Cisco router will join when you enable multicasting. The reason is there is a protocol called AutoRP. For AutoRP, this multicast address is needed. Anyway, we are not going to deal with AutoRP now. A long way to go. So we will see AutoRP later. Our focus is 239.10.10.1. 239.10.10.1 is attached to router 7 and router 5. So if I'll go and check in router 5 and router 7, I should be seeing that in the M routing table. Let me also parallelly open router 5. And also I'll open router 1 from where we are going to ping and test. You can ping from anywhere. I'm just keeping one router as a source, multicast source. Okay, so I'm going back to 7 to show you show IPM route. This router will have 239.10.10.1 because we have used IGMP group command under the loopback interface to join this group. Now you see 239.10.10.1, it is on the loopback interface. There is no incoming interface because there is no traffic coming with this destination so far. It says if I will receive any traffic, I'm ready to forward it on all this interface because this router has got this 2 interface and there is a member on the loopback who wants to receive it. But when we ping from router 1, what will happen is this will become incoming interface. It will be switched to incoming interface and this will be the outgoing interface. So traffic will be received on G00 of router 7 and it will be forwarded to the loopback interface where the real receiver is connected. Now other than router 7, no other routers, other than router 7 and router 5, no other router knows about this group called 239.10.10.10. I just showed you on router 2. I'll show you even on router 1. Even router 1 don't know that there is a group called 239.10.10.10. But router 1 is going to be the source for 239.10.10.10 shortly. Show IPM route. You see? There is no 239.10.10. Router 1 itself don't know that I'm going to be the source for this 239.10.10.10. As of now, router 1 has got no idea about the group because we did not use any IGMP command on router 1 to join 239.10.10.10. We have not done that. And there is no need for it because it's going to be a source. Now I'm on R5, show IPM route. This router will have 239.10.10.10 because we got the loopback interface with IGMP configured for the group. Look at this, 239.10.10.10 on the loopback interface. Fine. What is next? What about router 3? Router 3 will not know about 239 now. Show IPM route. This also don't have any idea about source nor the group. Source nor the group. See? No idea about 239.10.10.1. One more thing I want to tell you that none of the router knows the real source for 239.10.10.10. Even the original source itself do not know as of now because we have not generated any traffic from there. So this router itself don't know that I'm going to be the source. So no one knows about S source. You see? I would like to show that on router 7. This is the group. But what is the star? That's the place where the source will be reflecting. Source, once discovered, will reflect here. The address of the source will reflect here. But as of now, router 7 says I want to be in this group. I want all the traffic that is sent to this group address. But router 7 has got no idea who is going to send it, from where I'll get it, who will be the source for the group. No idea. No one knows. Let's go now to router 1 and try generating some traffic. You can generate traffic using ICMP. This is the easy way to test it. So I say ping 239 dot. See, I'm going to ping something like 239.1.1.1. No one will respond because no one has responded. No one has enrolled to this address. But when I put 239 10, maybe I can source it with my loopback. Now we will see router 7 and 5 responding. Not only that, every router will know now the source and the group. Every router will know the source and the group. See, router 7 is responding. 5 will also respond. Five responds, no others will respond. Done. Let's now go to R3. R3 earlier was not knowing about 239.10.10.10, but now it knows 239.10.10.10 coming from the source 111. I was pinging from this loopback, you remember? And it says the incoming interface was G00. Look at this interface. G00. That's the interface via which the multicast signal was coming in, and it was trying to forward via G01 and G02. G01 has pruned it. Means the signal went and R4 says, I don't want this. I don't want this. I'm not interested. So router 3 has pruned it back. But router 5 was interested in the traffic. So router 3 was keep on forwarding it to router 5. Whereas to router 4, it just forwarded once. And router 4 didn't show interest. So on G01, it has pruned. But again, I tell you, after a random period of time, it will again try to forward. Again, it will prune. Forward, prune. You waste the bandwidth, waste the process, waste the bandwidth, waste the process. It happens. That's why dense mode is not good. See this command. Show IP PIM interfaces. It shows now the mode that is running is dense mode. Don't worry about the version. The default version is 2. Dense mode. Alright. Fine. Now we are not interested in dense mode because it is flooding and pruning. Even router 6, if you go to router 6, and check the M routing table, show IP M route, even router 6 knows about this S, G, this source and this group. What is the use of it? no use. This is unnecessary. Unnecessary buffer utilization, process utilization. When R6 don't have anyone to receive the traffic for this group, when R6 is not a member of this group, when you don't have anyone as a member of this group, why R6 need to know this? Flooding and pruning is not good. Fine. So the best option to have very good multicasting with the proper utilization of bandwidth and processes using RP, rendezvous point, using sparse mode. Sparse mode uses rendezvous point. Sparse mode uses a mediator. Rendezvous point, gathering point. Rendezvous means gathering point. A mediator. So you can pick any one of this router to configure as a rendezvous point. And then make sure all other routers know who is rendezvous point. If you will make R3 as a rendezvous point, R6, R7, R8, R5, R4, R2, R1, everyone should know the location of rendezvous point, a reachable IP address to rendezvous point. So what I'll do is I'll use R3 as a rendezvous point, as we discussed now, a rendezvous point, and I'll use R3's loopback interface 3.3.3.3 as the address to identify the rendezvous point, and this address should be reachable from everywhere. R3 is going to be the rendezvous point. R3 is going to be the rendezvous point, and if you check the rendezvous point, there should be an address 3333 on the loopback. I'm going to use this address as the RP ID for router 3. So before I do anything, I want to first of all remove the dense mode which we configured earlier. The command that I use to configure dense mode is IP dense mode. You see, show run interface G00. This is the command I was using, IP pim dense mode. I need to remove this first on all the routers and replace it with sparse mode. Interface range loopback 0, G0/0. No IP pim dense mode. IP pim sparse mode. So I lost the pim neighbor, and now the neighbor has come back again. No, neighbor has not come. It didn't find the neighbor because the other side is not the dense mode. Sorry, sparse mode. The other side is the dense mode. Now let's copy this to a notepad. Also copy this no pim dense mode. And then put the sparse mode. Alright, so for router 6 it's the same 2 interface, so I'm going to go to router 6 now, paste this. Enable config T interface range loopback 0 G00, remove the dense mode, put the sparse mode, and and save it. This goes on router 6 and also on router 7 and also on router 8 and also on router 5 and now on router 4 and on router 3 we need to add 2 more physical interfaces. They are G0/0, 1 and 2. So it's going to be -2. Router 3 is also ready. And then what we have is, okay, one last router left, which is router 2. Loop back, okay, G00 to 3. And one additional, okay, to 4, up to 4, sorry, 4 interfaces. Is that right? The G00, 1, 2, 3, and 4. Excellent. That's all. When I paste this, we have replaced the dense mode to the sparse mode on all the devices. Done. Alright, so we should be seeing neighbors. Wow, look at this, how many neighbors we are seeing. All the neighbors have come. Let's check. Still coming. Show IP PIM neighbors. So we should be seeing neighbors. Router 1, router 6, router 3, router 7, router 8. And if you see, the mode they are running is sparse mode. Sparse mode. Sparse. The one with the bigger IP address will be the designated router. It's not that important here like OSPF. It's not that important here. In OSPF it is important. Let's see now. The next thing is I want to check one more command, show IP PIM interfaces. Here also you can see S, not D. Earlier it was D, now it is S, sparse mode. Right, good things are over. Now one more thing we need to configure, that is rendezvous point. Rendezvous means gathering, as I said. We decided to use R3 as a rendezvous point. Just to tell you that rendezvous point need not to be there in the path between the source and the destination. Look at this. This is our source, multicast source. Can be anything. In our example, this is the source, and this is the receiver, the group member, the destination. RP can be any corner router, even it can be R4. That doesn't matter. It need not to be R2, not necessary. It can be R4 also. What is the job of RP? Let's do one thing. We'll make R4 as RP. What is the job of RP, rendezvous point? That's the mediator, meaning if anyone in this topology joins any multicast group. Say for example, I'm configuring this on R7. On R5 I have not configured, assume. On R7 I'm going to configure. Before configuring, RP will not know about source nor the group member. But as soon as you put this IGMP group somewhere, R4 will know it. This RP, rendezvous point, will know it. How? R7 will go in search of RP. For that you should configure the RP's address in R7, so that it will go and search for RP, and it will tell RP, it's me, 7.7.7.7. Don't forget me, please. I want to join this 239.10.10.1 if you will receive any packet from any source for this address. Please tell me the source. Let me go and reach him and get the packets from him directly. See, I'm using the words very clearly. R7 says, tell me the source if you know, so that I'll get the packet straight from him. R7 is not saying, RP, you be the mediator, okay? You send everything, okay? You be a forwarder, okay? Know that okay and all. R7 says, just tell me who is the source for this if you know. I'll get the packet from him straight. I'll find the shortest path to reach the source. I'll get it done. So the packets are not always going to go through the RP. Only the initial, the very first packet to know the source, it was channeled via router 4 because it's an RP, but RP knows the source. Likewise, RP knows the group member because R7 was coming and enrolling. R7 was giving its address saying, hey, it's me. I want to know about the source of 239.10.10.1. Likewise, R5 will also go to R4. When you configure R5 with IGMP, it goes to R4 and says, even me, I want. And R4 now knows that there are only two people in this topology who is interested. RP is very clear who are all interested in this traffic to 239.10.10.1. Not only R4. R2 will know. Why R2 will need to know? Because the request, the enrollment request was going to R4 via this path. So R2 was listening to that. R2 is listening that G03 only interested. The member who is connected, R7 who is connected to G03 of R2. G03 of R2 only needs the traffic to 239.10.10.10. R2 knows it. So it need not flood to everyone when it receives the packet. It will send only to that interface where the enrollment packet came in. Yep. Now, no flooding as a result. We are going to now, okay, next step. The group members have went and enrolled with RP. Likewise, when you use any router, in our case we are going to use router 1's loopback as the multicast source from where the multicast traffics are going to be generated. Now, the very first packet, as soon as you ping, the very first packet will go in search of RP. For that, this also need to know who is RP. It will go to RP and say, hello, I am the source 1.1.1.1 for 239.10.10. Immediately RP will inform R5 and R7 about the location of the source, using which R7 and R5 will form straight connection, direct interaction with the source. So between the source and the group member, no more RP needed. They will find their own best path to reach both of them, the source and the group members, using the reverse path forwarding. What does it mean? When RP gives the address of source to R7, R7 will have like this: 1.1.1.1, comma. So this is the source and this is the group member. R7 will know the source now. What R7 will do, it will check its routing table for 1111. Router 7 will forward it to router 2. Router 2 will check for 1111. It will not check for 4444. Not necessary, because R4444 is not a source of the multicast. It is just an RP, an informer, a mediator. It need not to be there in the transit. So router 2 will take this path via G00, go to the source. That's how they receive the multicast feeds. So the packets will not be flooded to router 6 direction, router 4, router 2's G04 interface, or router 2's G03 interface. It will go to router 2 interface, go to router 3, and router 3 will not send it to RP. The outgoing will not be in RP. Only initially it will be RP. Later it will be only between R3 and R4, because there only we have the receiver. We are going to see all these things now. For that, first we need to configure the RP address. We need to give statically the RP address to all the device, including RP. To all the device including RP, we need to manually configure the RP's address. Let's start from R4 first. R4, I'm appointing you as an RP. IPPIM RP address. Boom, finished. Now R4 itself knows that I'm the RP. Please pay attention now. It is just an RP. No one else knows that this router is an RP. In this condition, show IP mroute. It has got no idea about 239.10.10.1. It has got no idea about router 7 nor router 5. No idea. But it knows one thing, that I myself is the RP. Alright. You remember we have already configured IGMP group on router 7 and router 5. Let me show you one more time. I did not remove that. Show run interface loopback 0. See? Router 5 is already configured with this, but router 5 do not know whom? RP. So let us inform R5 that RP is router 4. It's the same command, you see. Same command what I use in R4. IPPIM RP address. So there is no command difference. On RP also you put the same command, on other router also you put the same command, same IP. Now R5 knows who is RP. Now the game starts. Look at this. Show IP mroute. Show IP mroute. Now this guy, he already has this group membership using IGMP we did, and the outgoing interface is, listen, very important. The outgoing interface is loopback 0, sparse mode. It knows the incoming interface is G00. How? Because RP is via the direction. to go to this RP, it is going to router 3, and it's going to router 3, and router 3 will take to RP. Now if you go to RP, earlier when I showed you, there was no enrollment. No one enrolled. But now if you see, R5 would have enrolled by now. Okay, we need to generate traffic, only then the enrollment will happen. It is okay. You will know it soon. No. You know why? I know why. By this time enrollment should have happened, but router 3 don't know RP. You see, router 5 says show IP PIM RP. Router 5 says I'll use this address as an RP to register this address, this group member. Router 4 also knows that because he himself is the RP, but router 3 don't know. You see, router 3 show IP mroute. Router 3 has got no idea about RP. That's the problem. So fix it. What is the command? IP PIM RP address. Boom. Now we will see router 5 going and enrolling. Router 5 will go and enroll. Router 5 will go and register, saying I belong to this group. You will see that in R3 now. Sorry, R4. Earlier we were not seeing the enrollment of R5, but now that's it. This is it. You see, it says 239.10.10.1 is needed on G00. Earlier you didn't see this. Now you are seeing. It shows someone is there to receive on G00. R4 says outgoing interface. Actually incoming is also going to be the same interface in some time, because the incoming will also come this way. Outgoing will be like this, same interface. So already now it knows that I have someone to receive the signal on G00, because this guy came and enrolled. But R2 has got no idea about this. R2 show IP mroute. No idea about anyone. No 239, nothing, because this don't know about RP. But as soon as I put RP, see what happens. IP PIM RP address. Sorry, 444. Now the R2 knows that. Wait. Show IPM route. Now router 2 knows RP, but it need not to know about 239.10.10.10 because still R7 is not configured with RP address. So router 2 has got no idea about the group member and the receiver on the interface. When I go to R6, say I'm going to R6. R6 is not a member of the group. I'm just putting on R6 this command, show IP mroute. Sorry, what command? IP PIM RP address. I put this on R6. That will not make any big impact because R6 have got no group member. So when I go to router 2, I don't see big difference in the table. You see, it's the same output. But when I put it on router 7, there will be some change in router 2. Because the enrollment goes to for via router 2. So there will be some incoming and outgoing interfaces. Okay, that's it. Now I'm taking you to R7, R2 to show you the impact. Look at this. This is it. R2 says, I have a group member, but I don't know the source. The incoming interface of the group member is G02. Means here is the RP. Actually RP is here. The source is not here. But as of now, this is the incoming interface. And outgoing interface, the one who is going to receive the group member is, the signal is the group member who is via G03. Outgoing interface. And this is the RP address. Now, to go to the incoming interface that is towards the RP, this is the address. This is router 3's address. This interface is 10.23. That's called reverse path forwarding. But these things will change, you see. Please pay attention to this. When I ping from router 1, the incoming interface will not be G02. It will be switching to G00 because the real source is going to be this. Once it knows the source, right now it do not know the source. It knows only the RP. So it is pointing towards RP as an incoming. Once it learns the real source as 1111, using the RP, using the reverse path forwarding, instead of going to router 3, it will go to router 1. Here it will be 10.12.0.1, not 10.23. We are going to see this thing shortly. Before that, let me configure every router with this command IPPIM RP address. Every router. So we are finished on router 7. Let me make it on router 8. Router 8. Did I miss any router? Router 1 also should know. Router 1 is the source. Router 1 also should know. That's all. Now we are ready for testing. Pay attention. Before I ping one more time, I would like to go to router 4 and show you the status. Show IPM route. No difference. No difference. The enrollment is only via G00. That's what the incoming is. The outgoing for the incoming is none because the source has not been discovered. Now, going to router 1 to ping 239.10.10.1 source 101. Boom. First, it will go and enroll with router 4. And then router 4 will inform about the real source to router 7 and 5 alone. And all the routers in the path will change their incoming interface towards router 1. And now you will see the flooding won't happen to router 6 and 8. See, the response came only from 5 and 7. No others. Now let us go to router 2 first. Earlier, the incoming interface was G02. And it was going to router 3. That time it was not knowing about the source. But now it knows the source. So the incoming interface has changed to G00, which is towards router 1. The outgoing interface are two. One is G02, that is going to router 3 so that it can go to router 5. And the other interface is G03 so that it can go to router 7 and it can reach the loopback on router 7. See, there is no flooding on G01, G04 of router 2. No flooding and pruning. Just only the right interface forwarded. You see? So router 7 also, if you see, it need not to now go to router 4. It will go straight to router 1. Show IP route. It shows that this is my source. To reach my source, I'll go to router 2. I showed in router 2, it goes to router 1. So a direct connection between router 1 and 7 happens. Understand this. What I'm saying now is the shadow of all the new technology that you have today. You will have something like RP. In all the software defined solutions. If you take ACI, there we will call it as EPIC. If you take SD-WAN, there we will call it as vManage, vSmart, vBond, the controllers. If you take SD access, you will see DNAC. They are the one who controls the control plane, but they are not in the transit. Here, multicast control plane, who controlled? It is the RP. But they are not in the data plane. They are not in the path. Now let's add one more router, router 6, with the same multicast group. And then let's try pinging. First let's go to router 6 and add. Interface loopback 0, IP PIM, IP IGMP join group. Boom. Now earlier when I was pinging on router 2, I was seeing only G02 and G03 as an outgoing. Now I should see one more interface. Can someone name it? Sorry, I'm not able to hear you. Louder, please.
G01.
Yeah, G01. Let's see that. G01 and G03. Right, it has actually, what happened is it has got refreshed. Let's ping one more time and you will get the latest update. Ping again. Now you will be getting a response from 6, 7 and 5. Six, Done. Let's go back to router 2 now. Router 2. Show me the latest one with the source. Router 2 says this is the source and this is the incoming. This is the direction via which it is coming in, and I am forwarding only to G02 so that it can go to router 5, G03 so that it can go to router 7, G01, not G04. Because of G04 we don't have any receiver. What I'm going to do is I'm going to do another store. I'm going to do something now like this. I'm going to add another multicast address itself. Instead of 239.10.10.10, I'm going to say 239.20.20 and 2. Alright, on R8 I'm going to say R8 interface loopback 0 IP IGMP join group 239.20.20.2. Now you will see a new enrollment on R4. The RP will know immediately because it's an RP. RP, where are you? Where are you? Where are you? Earlier it was not knowing about 2020, but now it knows about 2020. Look at this. It knows about 2020, but it don't know the source. Now I'm going to ping from the same source. It can be same source or different source. I'm just going to use the same source for testing. To 2020. You know, only one person will respond. That will be router 8. Yeah, only one person will respond. It is router 8. And now if you go to router 2, there will be only one outgoing interface. No flooding. Router 2 for 239.20.20.20. If you see the outgoing interface, hold on. 239.20.20.20. This will be soon going away. Earlier, we had what? We had rendezvous point in consideration. So it is having it, but soon it will be removed. And this is the only interface, G02, where the receiver is. The incoming interface is this. Now let us ping one more time and then come and verify. Ping again. Soon this will be vanishing. G02 will be vanishing. Router 2. Because there is no business to go to router 4 now after knowing this source. You see, the only forwarder now is G04. See? Only outgoing is G04, no more G02. That's what I was telling you. RP is not in a data plane. RP is just going to say, okay, you can go there and find the source, find your own way to reach him, be happy. So RP's job is just to connect them, source and the group member. Not need to be in the path. No need to be in the path. No need to be in the data plane. Questions, please.
I'm good. I don't know.
Yeah, please.
For example, in an enterprise network, if I have to find multicast IPs out there, then I will be going to the edge router and show IP and route.
No. Just go to RP router and type show IP M route. You will know it.
Oh, okay.
RP router is the best place to see that.
And also, if I have to verify if there is any active traffic or like actively used or not, how would I check that?
Yeah, you can see that there itself, how many packets have been sent and received.
The timer which it was showing earlier.
Yeah, these things. Right. Any other question?
So Aaron.
Mm-hmm.
So can you minimize that? Yes. So first we did RP or R4. Okay, I'm talking about R3, R4, R5. So we did configure 239 or R5 and RP4. And you showed us there is nothing configured on interface R3, right? I mean the RP statement, correct? So after that we saw that okay, that traffic is coming or it is showing under 0 1 from R3.
Mm-hmm.
The same thing we will check on, we checked on R2 R7, correct?
Yeah.
So but at that time R2 by default it is coming from 02. We did not configure our RP, right?
Listen, RP was in R4's direction, which is on G02 of router 2. When we didn't get the real source, when we don't have the real source, when R7 don't know the real source, R4 needs to depend on RP to know the real source. So the real source information will be coming from R4, which will be an incoming interface to R2. Only then R7 can learn the real source. True or false?
Can you repeat that?
R7 was enrolling with RP. Why? To know the source, correct? So when you ping from R1, the source will come and register with RP, and RP will inform the source to R4. So RP is the first sender of this multicast source address. RP. It's not the original source. RP is the first incoming that was on G02, and then go to our G03 and go to router 7 and inform that 1111 is the real source. So that R7 uses RPF, reverse path forwarding, and get the signal directly from R1, and that is the time where the source becomes G00 instead of G02. Once the real source is learned, the interface towards the real source will be the incoming interface. Till the time, it will be the RP's address. The RP's direction will be the source.
Okay.
Hope I answered your question.
Yeah. For the same example between R3, R4, R5.
Same story. It was an incoming earlier as G01, and later the incoming became G00. Let me show you that. I showed you earlier the incoming was G01, but now I'm going to show you it will be G00. Show IPM route. See, the incoming now is G00. It is not G01. But earlier when we tested before pinging, I showed you here it was G01 towards RP. Yes or no?
Repeat that statement.
Now who is the source?
0 0.
Router 2 is the source for router 3. Correct or not? For this destination.
Correct.
Where is this destination?
20
Wait. Am I checking in router 3? Yeah, I'm checking in router 3. Let us focus on this address instead of... okay, let's focus on 239.10.10.10. Let me go on ping now. I'll generate the traffic. Okay. Now going to router 3. You see, the incoming interface is G00, not the rendezvous point interface. But earlier, before we were pinging, in the beginning when I showed you, after configuring this router and this router, I did not configure on this router, so it was not registering. Later I configured on this router. That time, if you go back to in the video, if you rewind back to the video and if you see, it will be showing G01 as the incoming towards the RP. But now the incoming is switched to G00 towards the real source via router 2. It's the same thing what you saw in router 2, you will see in router 3 also.
Okay, but between R2 and R3 we did not do anything. That is automatic, right? Using gathering point.
Why we did not do anything? We run PIM spats mode. That is the very important thing.
Okay.
PIM spats mode is there, and every router knows the RP address.
Okay.
PIM spats mode is running on every link. That is the important thing.
Okay. So one last question. So trying to understand difference, exact difference between dense mode and sparse mode. Dense mode, whoever configured in the multicast group, it will. What is that? Every router will get the request.
Every router wherever PIM is running,
Okay.
all the links that runs PIM will be flooding the packet, forwarding the packet, even when there is no one to receive on the other side. Whereas in sparse mode, only those interface where the receivers are, the forwarding of traffic happens, because when the group member and the source comes and registers themselves to the RP, every router now comes to know who really needs the signal, towards which the traffic will be forwarded.
Okay. Thanks.
So this avoids wastage of bandwidth, wastage of process of the routers unnecessarily. Alright, so we'll continue this. Multicasting is not over. We got another 2 more class at least in multicasting. Hope you enjoyed today's class. See you tomorrow, same time. Take care. Bye-bye.